Thank you. Thank you to Shlomi and to the entire JFrog team for having me here today. DevOps is near and dear to my heart. My job at Google is to lead developer tools. And my team's whole mission is to help our large, innovative engineering teams move as quickly and develop as safely as they can. So again, DevOps, very important to what I do at Google. Our team helps multiple developer communities. So it's not just about Google engineers, it's about Android engineers, Chrome developers, developers doing open source development, and developers using Google's cloud platform. So I've been in tech all my career, focused on software, and I can put on my dev hat, writing code, releasing, adding new features. I've also played pure ops roles, where I was just in an operator role, responsible for keeping production running. But most of the things that I've done in my career have to do with, the DevOps space. How do we write code, produce great apps and services, and then know how to reliably build, test, release, and monitor them in production? So I'm going to tell you some stories from my background and also from my team today to help give some more detail behind it. So while few people at Google categorize the developer workflow as DevOps, it is really the way we do development. And I believe some of our practices are already influencing the industry. I feel very lucky to do this work. And I know that might sound crazy to some of you, but as a developer myself, I started doing this work a couple of years ago. And it is one of the most challenging jobs that I've had, because how many of you have been completely satisfied and happy as developers? Just raise your hand. Matt's on my team. He can't do that. That's it, right? It's completely challenging. And we just keep raising the bar on our expectation in this space. So I find that incredibly challenging and exciting and inspiring. So I've worked on experimental projects, early stage prototypes, to legacy systems, building systems for financial institutions, ones with really small communities, ones with millions of users, sort of the range of startup to well-established enterprise companies. And what I really wanted to do as a developer was develop features. But what I spent most of my time on was all of the overhead associated with DevOps. So, thinking back to trying to debug builds, trying to figure out why tests failed, trying to understand why the release failed to deploy, trying to look for error rates and debug in production. So much time was spent on that overhead. And I believe developers deserve tools that automate away this overhead, because we want to be freed up to build apps, to work on new business ideas, to develop new features. So our intent in DevOps is to reduce that overhead as much as possible. And I'm going to share some examples of that. It's been awesome to work at Google because we have made a priority to do this. We've made significant investment in this space. And so I'm going to talk today specifically about the Google developer journey and how we're trying to live these principles of DevOps. So as developers, we want to build things. But we're building things on a rapidly evolving stack. And I think over the next 5 years, we're going to see such a change in both computing and software engineering, more so than we have in the last 20. And I get the sense that it's an explosion of innovation. I mean, look at all the partners here today. Look at the products that are being developed in the space to help developers. So as software gets more and more integrated into our lives and our businesses, I believe most companies have the exact same challenge that Google has had since our beginning. And that is, how do you create functional, easy-to-use software and be able to operate it at scale cheaply, reliably, and securely? And we as developers, right, and as members of the software community, have an opportunity right now to be part of this change, to make it better for ourselves and for others. I think software development is going to look very different in the coming years, and the main reason is because of all of the contributions to improvements, and specifically in DevOps, which is where we spend a lot of our time. Okay, how many humans in the room? Okay, audience participation. It's the morning, we're getting started. So I like to ground this experience in remembering that it's about people. What we're doing is about making people more productive, and people are our most valuable asset. So I think everything that we're talking about in the next 2 days in some way comes back to people, because people are developers, and people are operators, and people are innovators. And I'm going to share a couple of things that I found at Google that just to remember about the people and why we're doing this. So this goes without saying. Hire well. Hire the right expertise. Cherish the people that you hire. Understand that different developers need different levels of support. And understand that developing isn't easy, right? When we're in this rapidly changing environment, it's difficult to keep up with the rate of change. Next thing, autonomy is important. I believe that when you hire well for the need that you have, point people in the right direction and let them go. Be there to support them, encourage risk-taking, and I know some of these are really hard in practice, but I'm going to give you some examples of how we do this at Google. Google measures relentlessly, and I'll talk about some of the measurement in our DevOps space, but we also measure things like people performance and evaluation. But in addition to that, we measure happiness, we measure respect, we measure psychological safety, we measure inclusion, because we want our culture and our environment to function in a way that every developer can thrive, regardless of their background. And finally, seek out the passionate, because passion is a force multiplier. When people are passionate about the thing that they're working on, they're going to bring so much more of themselves to the problem that they're solving or the incident that they're trying to resolve. So I know some of you didn't raise your hands when I asked if you were humans, so I think there's cameras in here. We can sort of figure out who that was. So people make up, the culture binds people together. So what is Google's culture like? Well, it's a very diverse development environment. The size and makeup of the team, the products that we're working, the technology stack that we use, the team and organizational structure, the geographic footprint. I mean, I could go on and on and on. And it's chaotic in many ways. So that chaos, we've helped sort of look at the values and principles of our culture and create a technical foundation and shared infrastructure to help us in this chaotic environment where we have autonomy for developers to take risks and we have focus. So diverse environment, relentless metrics, code commit to deploy, number of releases, bugs closed and opened, number of rollbacks, and the reason we capture all this data is to learn from it, because it enables us to really kind of live this principle of fail fast and fail small and course correct as we need to. It also helps us look at the feedback cycle around code optimizations and the find and fix cycle. And there is no ultimate productivity metric at Google for developers. I don't believe in that, because developers are doing so many different things. But we use these metrics to help identify blocks in our development workflow so that the team themselves has the autonomy to learn from that. And it's not dependent on someone, upon high to sort of say, this is what needs to happen. We're trying to embed that culture within the teams. Finally, blameless culture. This is really easy to say, and in order to live it, you have to practice it daily, and you have to incent and recognize values as they're being lived in the culture. We do blameless postmortems all the time. I'm going to show you one today. I think this is just a critical part of the openness of the culture. So I have a team a couple of years ago. They were working on some improvements to how we were running tests. And they'd been working for a while. And they wanted to get it out to users within the Google community. I remember this day. And we launched it. And has anyone heard of the term success failure? Yes? Any nods? Yeah. It's where you do something and it's very successful, and then you have a complete meltdown. So we opened the system up. People heard about it, kind of went viral within the engineering community. We didn't have any limits. People started using it in ways that we didn't expect. People started using it at scale we were not ready to handle. We had not done our homework around productionization and operations. The team was working incredibly hard, and we had to hit the reset button on this project. We had to bring in people outside of the team to help us, because Google saw the value of what we were doing, but we could not continue in the situation that we were. And we all learned a tremendous amount about the system itself, about the design failures, about how you approach a project like this to do sort of incremental adoption, to learn from your user community. And we wrote many postmortems. We had many open discussions, all levels of the organization about this. Our ads organization was depending on it, Geo was depending on it. It was critical for the business. So this is something that I really value and feel like is a strength of the culture of, when we can develop, operate the service, and feel like we're not going to be punished for making mistakes, we're likely going to take more risks, and we're going to collaborate more effectively with each other. So be intentional about the engineering and developer culture you're trying to create. I think it's very important because it comes back to the people. I think you can have a great strategy, but if your culture is not great for your people, you're not going to be able to accomplish as much. Okay, so I'm a developer. I sit down. My workflow is essentially learning about the code, writing it, versioning it, searching it, and then finally build, testing, and releasing it reliably as an engineer. So any Go developers in here? Go, yeah. So developers, we love languages. We create more of them all the time. It's hard to keep up with the language ecosystem, so we support a variety of languages, C++, Java, Go, Python, and many others. So you can use what you're good at. But here's an example scenario. So a developer comes in, writes a patch to a component, lots of dependencies in the code base. It gets tested against the entire code base, passes. I send it for review, LGTM. That's pretty good, right? There's a tremendous amount of automation happening in the background to enable this sort of simple workflow. And I'll show you some examples of these tools in a second. So Googlers want an amazing development stack, and as I said before, they're already raising the bar. I think one of the reasons it's successful is that we have this integration between code management tooling and our build and integration test pipeline. So you get this great feedback loop that happens from, oh, I'm seeing the error rate go up for this problem in prod. I can actually come back to the code and see where this problem is coming up, and I can fix that code. So we're really trying to optimize that code find and fix cycle and optimization. As a developer, I have access to a lot of common libraries. That leads to its own set of complexities that I'll talk about in a sec. And it just kind of works. Here I say zero DevOps. It's not really zero, but we're constantly improving it and trying to minimize it. And we really have no limits on that. So we have the ability to scale and continue to increase the number of engineering teams, the number of products, and the speed at which we operate. So speaking of scale, this is I call it the vanity slide. But you talk about code velocity, 45,000 submits in a workday, 20,000 code reviews. Then you look at the continuous integration pipeline, 800,000 builds, 150 million plus tests. Just for reference, the Linux kernel has 20 million lines of code and 50,000 files. The Google repo has 15 million lines of code and 250,000 files that change in a work week. So we are really optimizing for code and release velocity and bringing a lot of automation to that. So talk about the people, the culture. How do we put our hands around sort of the elements of the culture and how those get expressed? And there are three of them that I like to think about that go through the entire engineering developer community. We prioritize readability and maintainability of code. It's a top priority for us, and we invest a lot in it because quality is important, and if you don't add that upfront investment, you're going to have problems when you're operating the service. So they're really connected. Automation, we rely very heavily on automation instead of humans because humans, as we know, we're expensive and we're error-prone. We favor and choose transparency and sharing over secrecy and siloing in our code base. We believe that that transparency enables trust, fosters that trust, and then enables developers to take action based on that. So we have lots of APIs internally, and API breaking changes happen on a regular basis. And they happen because we have these common libraries that we use throughout the code base. So how do you change and evolve an API when an API has 10,000 plus call sites? So you use automation, right? You use automation and analysis. So we can analyze, compile, test, generate CLs, automatically make the change for those API changes, and it runs in minutes, right? And that's sort of the speed and the expectation that the Google developer community has. And I think why we're able to maintain the code throughput that we do have. So a little bit more, what are the implications? Well, we have mandatory code review. And that's a significant investment. Our code review tool is used daily, multiple times. And this is an investment in education and improvement for both the reviewer and the reviewee. We have tools that help make sure the code is formatted correctly with our standards. And also that we've run as much automation as possible to identify any machine detectable defects in the code so that the developer doesn't have to worry about that. And this is kind of what we think of as our robot reviews. Automation, it's really about quality, stability, and security. We automate as much as we can, relying on our build system. It's highly distributed, parallel, we cache results. We're really trying to optimize and tune that so that we can scale to the demands that we have. And transparency, every developer at Google has the ability to view and search and modify the entire code base. And so what does that mean when you have transparency? Well, it means that if the code is open, developers can come in and help modify bugs and fix bugs together. When you have fast access, you can answer interesting questions. You can query the code base and find something that you might want to reuse. So those are some of the elements of our culture and sort of the implications that they have within our workflow. At Google, we run some of the world's largest services, Google.com, Gmail, YouTube. Our goal is for developers to move as quickly as they can and ultimately lead to more predictable operations. That's what we want. So we don't call it DevOps, but I think it is DevOps in terms of the way we develop. Okay, so we're going to lead up to the developer journey. So I'm a developer. What do I want to do? I want to ship as fast as I possibly can. If I'm an ops person, I don't want you to break anything. Don't break anything ever. And when we get into the DevOps space, I think the beauty and the magic happens when we pull those together. When we learn and improve the code by bringing development, writing the code, and ops, running and operating the service together. So everything is around speed and safety. And if there's one thing that I want you to take away about Google's DevOps, it's that it's this combination of two things. The centralized infrastructure that developers get value out of and feel like that infrastructure has their back to develop safely, and the culture and environment that we create, which comes back to the people and how you help the people thrive. So let's go on a little journey. Is everyone ready? Okay. Okay, so I'm a developer, and I come in the morning, and I'm doing that patch that I said before, where I want to change a component, has a lot of dependencies. I can come in, and I can search, and I can browse the code. I can find semantic cross-references. I can look for reuse. Here you can see an example of references to and from. And I can just read and look at as much code as I want to learn. I can ask questions of my teammates, can figure out what I want to do. But then I'm writing code. So when developers are writing code, we're surfacing what we call insight and intelligence directly as they're writing the code. So you can see here an example of an invalid conversion. So this is not only improving readability and the education for the developer, but it's also ensuring that we find things before we get to submit, right? Because the longer things go in the pipeline, the more time and investment you spend in fixing them. And we talk about robots operating in the background. I like to think of it, how many people here have pair programmed? I've done a little bit. What if you had, when you were developing and operating your service, this helpful human to the side who was always there to find things that you might have missed, to help you, to make suggestions, and maybe sometimes just do it for you so you don't have to worry about it. It's like reducing the cognitive load. So that's what I really want. I challenge you to think about how do we create that sort of pair programming experience for people using DevOps tools and products. Okay, so I said before, code reviews are a big part of our process. 20,000 a day, it's a huge investment in what we do. So they include static analysis, they include build and test results, other information helpful. We have pre-submit checks, so those are tests that run to find out what's going to break before you submit it. You've got a bunch of comments, and you've got links to bugs that need to be addressed. You've got links to the analysis that was run. So besides kind of the pre-submits, the automated code reviews we're doing, and the human code reviews, we also do things like show if there's been a rollback, show that you can roll it back, but also show if something's been rolled back already. And I think there's a lot of value in that to give more information to the developer about the state of this code. So you have this, developers have these single panes of glass, depending on where they're in the workflow, to take action to make the code better. Okay, so here's an example. Some issue that doesn't work with IE8. We have a prompt here to go fix it. So we have a suggestion. You can also say, you know, this isn't useful, and that's helpful for us. But we can take it one step further. You can see here in the second example, there's string comparisons using equality instead of value, reference equality instead of value equality. So we have a please fix, but we have a suggested fix, and we'll show you what that fix is so that you can just apply it, and we'll take care of it for you. So you can see this progression of, you know, here's the insight when I'm writing code. Here's some suggestions, you know, prompt to fix it, show me the fix, and then apply the fix. So you can see how we could be on this path to really this pair programming experience where there's much more automation in terms of how you improve and optimize the code. And again, this is a commitment that not every company makes in terms of code review, right? Startups are not doing this amount of investment in code review. So, you know, this is what we found to be helpful given the size and velocity of our organization. And I think there's a lot of opportunity in this space with the intent to reduce the time and effort that developers spend. So once the code's submitted, we're just going to test continuously. So most teams have a build monitor, so they're going to get, they have a dashboard to identify failures and identify culprit changes. As a developer, I can sync to the latest green change list, and I have a single pane of glass to look at all of my test results as I head into release management. And given that we test the entire code base after every repo update, we have a lot of consistency before we release, and all of that information is available. We also do things like integrate CI with release management and then all the way through to monitoring and alerting so that we have this transparency and developers can see what's going on. We're constantly running tests, but we're only triggering them if a test depends on a change. We run with different flag combinations, and we're accumulating all of the results of these tests. We're doing things like automatically identifying and isolating flaky tests, because we don't want to waste time on that. We have capabilities to quickly identify culprits so that, again, we prevent time that a developer is going to spend trying to figure out what happened in the build cycle. So intelligent test selection is really critical to what we're doing at Google in our DevOps workflow. And without it, I don't think we could scale. So here's just an example, simple example. The developer only modifies logging.java. We're not going to run transaction and authentication. And this is made possible by using Bazel, which is our Google's build system, which is integrated in with our continuous integration and build system. So I mentioned Bazel. I wanted to bring it up because this is an example of Google engineering contributing in the open source community, which, you know, I believe in the value of collaborating and open sourcing pieces that we've invested in so that other developers can get value out of that and contribute. Bazel's just one example. It's being used, we use it ourselves because we dog food, but it's being used by Braintree and Stripe, Dropbox, and others. We contribute to projects that other companies start. So Spinnaker is an example of that for release and deployment. So as a developer, I believe it's not about just making your own team productive, but it's also about contributing and investing into the entire community. Actually, Dan Cerulli is going to give a talk later today about some open source work we're doing and how to manage microservices. Okay. Anyone carry a pager? Or phone now? I know. Anyone? No? No one carried a pager? In the past, did you carry a pager? Can't see. Yeah, me too. Me too. I always tell people this story, which is true. I used to sort of sleep with it under my pillow at night and just hope and hope that it didn't go off. You know, just like, oh, I don't want to get up. So I'm going to walk through an incident. And by doing this, I want to show more the operations side and how it ties back to development and the level of automation that we have. And I don't think we could do any of this without our blameless postmortem culture. I don't think we would have this level of openness because, again, you know, there's no threat or worry about being punished for making mistakes and contributing to solutions. Okay, so this is the case study. Again, going back to that patch example from before, we submit it, we test it, we create a release, we push it to QA, we push it to production, and then, wait a minute, error rates start to spike. An alert fires, on-call starts investigating, it escalates, we declare an incident. The team works to do the root cause analysis. We create a patch, we push that patch to production, we write a postmortem, and there are a whole bunch of actions that come out of that that we need to work on. So let's start. So this is, I'm showing you actual tools. A lot of the stuff is blanked out. Some of it's still there. So this is our release management tool, and this is where we're actually creating the first release. You can see down there the candidates created. So we're in the process of going through deployment and releasing and getting ready to push this out. So we do rolling updates, and we have the ability to sort of limit the amount of task disruptions so we can, that are imposed by the rollout updates because we want to maintain the highest quality of service. You can see this is being rolled out to QA, and you can see all the updates that are happening to the servers. You know, log information, lots of links that you can click to get more info. And this is this is the bad part, right? This is the part that happens no matter what we do, right? We make mistakes. So you can see the production push. You can see the alert firing, and then you can see these error rates just spiking, spiking. Something is clearly wrong, right? On-call gets involved at the alert firing, and then as it escalates, we declare an incident, which is, you know, user-facing outage. So I'm on call. I now get the alert on my phone, and there's a bunch of information in here to help whoever's on call. There's a link to the playbook. There's the rule that shows what was triggered in the alert. There's a summary of the problem. There's a bunch of similar tickets. There's follow-ups. There's links to other failures that are going on. We're trying to get everything available at someone's fingertips to try and resolve the issue, find the root cause, and implement the fix. So again, come back to that concept of readability and transparency. It's all there. It's all there at our fingertips. We declare an incident. We have a comms lead. We have, you know, an incident lead. We have status updates going back to the community about what happened, and are really transparent with the community about what's going on. What's the source of the problem? We know what's happening. We're working on it. We will update you as soon as we have a fix. And here's an actual, you know, people are on IRC. Yeah, it's bad. There's thousands of projects. You know, this is actually a team that was across Munich, New York, Mountain View, and Seattle, all working on this issue. And it's not just the ops, right? It's the development teams that, you know, had the issue in the first place. So it's the team working together. You know, whether it's primary or secondary or tertiary on call, you know, everyone's trying to contribute to the solution. And then they find the issue and they push it. And, oh, I like that graph at the end. That makes me, that's good. Looks better, right? So then we get together. So everyone, wipes their brow, puts their phone down, walks away from the keyboard, sort of. We write the postmortem. And the postmortem includes a lot of information. It includes, a summary, who was involved, details around the actual problem, and a whole list of things, action items, that we need to do after. And we have meetings, or we have, chat sessions to review progress on these action items to make sure that we get them done. Because we don't want to have these problems again, right? We want to make new mistakes. We're trying to get that continuous improvement cycling through ops back into development. I think that's really where the magic happens. And we do these for projects too. So I mentioned that example before of the test release we did. We'll do these at project perspective, not even the technical details. We'll think about, okay, what were the decisions we made? What was the impact to our users? How can we improve? And then we get back to work and on to the next thing. So if we're doing our job right, developers keep raising the bar, and can't make engineers happy, but hopefully we can make their lives a little bit easier. So I hope you've seen sort of the progression of these tools, how much collaboration and co-development is critical. And it's because it creates this level of accountability to help each other, fix things, debug things, learn from each other, and really work in small teams. Sharing code among developers means that we're constantly trying to increase the rate of reuse, which means that developers are writing new features and new code or optimizing the things that are shared, which increases our velocity. Engineers want autonomy, not just in the direction they're heading, but in their tools. This is the last audience participation, I promise. Any Emacs users?
Any what?
Emacs.
Yeah, Emacs.
Okay, VI. Yeah, I use VI. Who wants to force an Emacs user to use VI? I mean, it's never gonna, well, yeah. That was I would left myself open to that one. But the thing that I'm trying to make is I believe in supporting developers to have choice in what makes them productive. So there's some things, right? We have the standard foundation, but developers have a lot of choice, language choice, the tools that they use. I believe strongly in that. CI, ULI, sorry I got distracted by the piano. We use it a lot ourselves. So dog fooding, we always try and do things ourselves before we push them out to users. And I think that makes us make better products and have empathy, right? Empathy for each other, empathy for the user experience, understand where their pain points are. And we wouldn't do that if we didn't use the tools ourselves. I'm a big fan of doing hackathons internally where we try and use products that are under development as developers where we can identify where that pain is. Because we're going to build something better. So, accountability, I talked about that. We have chaos in the culture, but we also want accountability, and that needs to be balanced. So some chaos is a good thing, but I encourage you to think about where are there places where you can decentralize and empower your teams. And I think you can make this easier by trying to get small teams, manage the size so that you can have that autonomy, try and keep the hierarchy flat. But also try and experiment with things like peer-driven evaluation, because then the feedback's coming from within the team and the culture continues to evolve within the team. I think we're able to do this because of this technical foundation that we have in place with our build and test systems and with the systems that we have around code management. So please try hard to say yes to new ideas, even knowing it may be a little chaotic. And empower engineers and developers to, create the next new thing. I think that's why we're all here. So, all that sounds great, right? Sounds good? No? Maybe a little? Maybe a little? Okay. Well, Google is not perfect. We have our own struggles. It is never fast enough. I don't think it's ever going to be fast enough. I think maybe, well, let me tell you a story first. So this was a couple years ago. This new developer joined from the industry, and he sent what is basically a love note to my team. It was like, the tools are great. I'm so productive. I can't believe how fast it is. right? So fast. And, 2 months later, he was filing feature requests about it was too slow, like there was a problem with tests. I was like, wait a minute, 2 months is all it takes. So, I think maybe it'll be fast enough if you're writing code and we're running the build and we're running all your tests, and it's kind of like typing something into, Google.com into the search result, I think it's that level of speed that we're expecting, and I actually think that's good, but it's challenging. It's challenging to keep up with it at scale. The rate of change, incredibly fast. You saw before, 45,000 commits in a day, 20,000 code reviews. Stuff is gonna break. It just does. So the more we invest in tooling for our DevOps pipeline, we're going to be able to respond to those breakages. And the more we invest in automation, the better off we're going to be. Quality processes. As teams grow, as companies grow, I think quality processes can get in the way. And sometimes at Google they do. Finding and fixing bugs, it's difficult. I think there's a lot more automation we can do there. But it's tough. You start to notice gates being put in around releasing and launching. It cuts down velocity, it creates bureaucracy, really working to have a balance as the organization grows. So, what do I think about what all binds us together? I think we all share a lot of these goals. And maybe we're all implementing them in different ways, we're using different products, we're bringing the uniqueness of our culture. But I think our ultimate goal and outcome is developer productivity. And we can do that through a combination of tooling and automation, creating transparency within the DevOps process. And I don't think we can forget about security in the world that we live in today when we're doing development. We need to remember that needs to be an important component. And scalability is also a big part of this, right? Because I don't think we want development teams or developers to be in a position where they create something very innovative, they push it to production, but they can't scale it to as many users as they possibly can. We want those capabilities for planetary scale. So, it isn't just about reducing overhead. I know I started off talking about that, reducing overhead. I felt a lot of pain in that, and a lot of developers do. But I think it is around optimizing and making developers move faster, sort of like better software faster. And I can't imagine, I know Google may be living in the future, may not, but I can't imagine what software development is going to be like in the coming years. I think it's a very exciting time to be a developer in terms of the rate of change, the level of access we have, the focus on us. So I invite all of us to be part of this journey together. And I hope we have an opportunity to collaborate on improving some of these tools together. And I want to say thank you again to JFrog. Thank you for having me. Thank you all for being here. I look forward to hearing the talks and exchanging ideas with you. Thanks.